Welcome back. We're going to go over machine learning best practices and responsible AI. But before we get started, hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. So, AWS tests understanding of how services integrate for production machine learning systems. These principles derive from the AWS well-architected machine learning lens, unifying knowledge across AWS machine learning services in a cohesive design thinking essential for production deployment. So, what are some responsible AI principles? All right. So, fairness avoids bias in training data and predictions. Explainability provides insight into features driving model decisions. Privacy and security guard against training on or exposing PII and sensitive data. Safety ensures models don't cause harm or produce erratic outputs. Controllability enables tuning, oversight, and rollback. Veracity and robustness ensure truthfulness and resilience against bad inputs. Governance and transparency define rules, limitations, and share known risks. Let's go a little bit into the AWS responsible to AI tooling. Okay, so there's a couple of tools that AWS has for responsible AI. Amazon Bedrock evaluates foundation models via test prompts, supports LLM evaluation with accuracy and guardrails, and proves useful for generative AI agent safety and tuning. Open the Bedrock console, choose a foundation model, and use the model evaluation tab to test prompt responses. Then you have SageMaker Clarify. This detects bias in datasets and predictions, generating explainability reports showing which features influence predictions, and operates during training and inference. For feature impact analysis and loan approval models, open the SageMaker Studio, navigate to the experiments and trials, launch a Clarify job, uploading some datasets, and visualize the bias and explainability reports. Then you have SageMaker Model Monitor. This continuously monitors deployed models for data drift or prediction errors, sending alerts via CloudWatch. You can go to your console, see a deployed endpoint, select the monitoring, enable model quality monitoring, and then configure a sampling and alert threshold. You have Amazon Augmented AI, or A2I. This enables human review workflows using reinforcement learning from human feedback with your choice of your own workforce or AWS's managed teams. You can go into the A2I from the SageMaker console, create a human review workflow using templates, and choose review types like image classification or text output. SageMaker governance features include maybe role manager to set fine-grained permissions per team member, model cards to document model intent, risks and limitations, and model dashboard to provide a unified view of all models and metadata. Right. So, what are some design principles? So, AWS advocates for 12 design principles mapping to machine learning lifecycles. All right. Ownership assigns model owners for drift, tuning, and updates. Protection secures data and models using KMS and IAM. Resiliency uses failover and checkpointing through SageMaker managed endpoints or managed spots. Sorry. Reusability stores and reuses trained models via model registry. Reproducibility uses pipelines and lineage tracking. Resource optimization, right sizes instances like INF2, G5, TRN, ML dot. Cost reduction prefers managed pre-trained models. Automation uses CI/CD and continuous training. Continuous improvement uses model monitor and A2I feedback. Sustainability selects greener regions to avoid GPU overuse. API abstraction can deep couple apps via API gateway endpoints. And microservices can use Lambda or Fargate for model supporting logic. I know, it's a lot. All right, so what are some business goals here? All right. So you're typically going to work backwards from business value rather than forwards from AI hype. Define your KPIs, your ROI, and your opportunity cost. Align that with compliance, privacy, and licensing considerations. SageMaker Clarify can feature impact reports to justify explainability trade-offs. SageMaker Experiments can evaluate explainability versus accuracy. SageMaker Role Manager can assign accountability. For predicting subscription service churn, define a return on investment as retained revenue per dollar spent on training and infrastructure, as an example. Let's go into some of the life cycle. All right. So data collection sources include S3 databases and logs, ensuring licensing and ethics compliance. Data processing can use Glue or Data Brew for PII detection and feature preparation. Feature engineering can use SageMaker Feature Store and online and offline modes for normalization, encoding, and scaling. Then you have model training. This model training and tuning can use SageMaker training jobs, hyperparameter tuning, and auto ML. Model registry can track versions, owners, and accuracy for reuse and rollback or A/B testing. Your deployments can use SageMaker endpoints or Amazon Bedrock for inference connected through API Gateway or Lambda. Then you have models. All right, I'm sorry, monitoring. All right, monitoring and feedback can use SageMaker Model Monitor, A2I, and CloudWatch to set up drift detection and alerts. Then you can have retainment, and you can improve using this new data from inference or logs to automate a SageMaker pipeline and scheduler. All right, let's talk about cost. Oh, I thought I had that. Oops. Okay, so all right, cost optimization, right? So you're going to want to use pre-trained models from Hugging Face on SageMaker or Bedrock, right? You can use spot instances for up to, I don't know, 50 to 90% savings during training. And you can optimize the instance types by choosing the inference types, TRN or INF for inference, TRN for training, and G5 for GPUs workloads, right? And you can select greener regions like US West, Canada Central, Ireland with lower carbon profiles. And you can reduce training times using SageMaker Debugger for training jobs. And then you could avoid overkill by using XGBoost or Linear Learner instead of LLMs when suitable. So if we deployed a model, it would take a long time to go through. But for the exam, remember this. When questions ask about implementing explainable machine learning systems, detecting model bias, ensuring responsible AI deployment, or optimizing machine learning infrastructure costs, understanding that these best practices demonstrate practical knowledge of production-ready machine learning architectures and integrating AWS services across the lifecycle from data prep through deployment, monitoring, and continuous improvement. This can maintain fairness, transparency, and cost efficiency. So before we get out of here, hit the like button, subscribe, and share. But thank you for joining, and have a good day.